Hi, Brian Maestri back. Now, again, continuing on with the Southwest Coastal case study for the risk assessment course. Now, this part of the presentation, we want to look at the inputs and the calculation of uncertainty using the HEC-FDA model. And we're just going to concentrate in this part of the presentation on the engineering input or inputs to stage probability relationships. Before getting in specifically into the engineering inputs, just want to talk about risk and uncertainty in general. Risk is the chance of something happening. Is measured in terms of the consequences, what bad could happen, because that's usually how we think of risk, right? It's not of the good things, of the what could go wrong, and the likelihood of it happening. It's sort of like when I went to my doctor a few years ago. I was having my heart was not beating regular, and he said, "Oh, you have atrial fibrillation," and I said, "Oh, okay, what is that?" And he said, "Well, that's not a good thing, and I'm going to give you a baby aspirin to reduce the risk of having a stroke." And I said, "Well, what's the chances of having a stroke?" He said, "Oh, it's 1 in 400 right now, and by having that little baby aspirin, it'll be reduced." And I said, 1 in 400? Oh, Hurricane Katrina was a 1 in 400 chance. So yeah, I take it seriously, and I take my aspirin every day. Uncertainty is the possible errors in the methods that are used to calculate your parameters. So you know how uncertain you are, because then that leads to risk that something could go wrong in terms of what exactly you produce. So risk and uncertainty, it must be quantified on the current guidelines. In the traditional method, it was one number. It was a single point estimate. Risk analysis instead provides a range and a probability of occurrence, a probability distribution. So we have computer models that use Monte Carlo simulation, and we'll look at that later in the presentation. And specifically, the HEC-FDA model incorporates Monte Carlo simulation in calculating damages and benefits. So Southwest Coastal Louisiana, looking at the configuration of the study area, it was broken into 90 study area reaches. You can see them, in which you had a set of water surface elevations, stage probability relationships that were unique to each of those 90 areas. And so those became our reaches. And you can see that in the HEC-FDA model, they have a dialogue across the top, and you can see under configuration, you can set that up, and you can set up your reaches with a beginning and ending station. Just wanted to show you how that looks in HEC-FDA model. And so we had our stage probability relationships, which are the study's water surface elevations, as you can see in the hydro engineering portion of the model. And we set it up for 2 analysis years, 2025 and 2075. The model will allow you 2 years. And you can provide up to 8, and you have to, in fact, provide 8 stage probability relationships, along with the invert of the lowest elevation in a reach. And the water surface profiles or stages for Southwest Coastal contain the rainfall component along with storm surge, which is the H&H model used for that is the ADCERT model. It's used for coastal areas. We did not use discharge probability or discharge stage relationships for Southwest Coastal, with this being a coastal area. We went straight to the stage probability relationship. Here's how they looked, as you can see, for without project. I just show here that here are the 8 probability events. You can see the probabilities in the top row. And the first reach is for an area that is north, in the northern part of the study area, around the Lake Charles, up 50, 60 miles away from the coast. And you can see the stages associated with probability events. As you can see, as you get to a less chance. So the way you read that is there's a 99% chance that this stage will be exceeded in that year, 2015. That was the study year, and then this was for the base year when we expected something to be built, a solution. And so we had the stages in that year for the 1-year event. And then in 2075, in the future, you can see those stages are higher. And the stages are increasing as you get to a less probable event. In the area south, you can see that generally these stages, especially when you get to the less frequent events, the 100-year event, they become much higher relative to the northern reach in the south. So if that all makes sense, let's see if we can answer some questions about those. What is the approximate ground elevation for the study area reaches? Well, you would look at the 1 year event, and if you look, remember it was around 2 feet, was around the 1 year event, because you expect, there's a 99% chance that in that year that elevation will be exceeded. So that's pretty close to the ground elevation. Why are the stages so much higher for the south reach relative to the north reach? Well, it's right near the Gulf, and on very large events, those stages then come right into that area and cause a lot more of a flooding than you would 50 miles north from the coast. What could be causing the stages to increase as we move to the future? Well, sea level rise was when we move from 2015 into 2025, especially from 2025 to 2075, projected sea level rise and land subsidence. This is a marshy area, the land subsiding, and the water is increasing. So how would a structural alternative, such as a levee along the coastline, affect the water surface elevations or stage probability relationships? Well, you would expect for every one of those probabilities to have lower stages, right? Lower stages means there's less water, and so that also should lead to less damage if there's property there where the water is going. And how would a non-structural solution affect the water surface elevations or the stage probability relationships? This is an important question because it really would not. It's non-structural because it does not affect the height of the water. Instead, what you're doing, you're trying to make what is there, those assets there, less vulnerable to flooding. So you elevate them, you flood-proof them, you relocate them, you buy them out. So it doesn't really affect the stage probability relationships. So going from there, I just wanted to test your knowledge. What is the probability of a given storm event occurring in any year? Just to make sure, it's 10-year event, 1 divided by the recurrent event. So there's a 10% chance of a stage associated with that event being exceeded. For a 50-year event, 1 divided by the recurrent year, so it's 0.02, so there's a 2% chance of it being exceeded. And for the 100-year, we all know that one, right? It's 1 divided by 100, or the 1% chance. And for the 500-year, it's 0.2%. So that would be 0.002 if you didn't have the percent sign. So the formula there, as you can see, is 1 divided by the recurrent event equals the probability, or what we call the annual exceedance probability. Notice I said, what was the chance of that stage being exceeded in any given year? So that's why we usually call it AEP, annual exceedance probability. And to get to what this course is really about, the risk assessment. So how do we calculate uncertainty? Those stages were all one number for each of those probability events. Well, we put in the HEC-FDA model requires an equivalent record length, the number of years of gauge information you have available. For the Southwest Coastal, we had 50 years, and that's entered into the model for those stages. And as you can see here, it gives you confidence limits around your stage. So here's the probability events, and it interpolates in between the events. So the 0.10 we said is the 10-year event, and the 0.50 is so that means that's the 2-year event. So there's a 50% chance at this stage 6.07 will be exceeded. But notice now you have confidence limits around it. 1 standard deviation, so there's a 67% chance that 6.07 could be between 6 and 6.15. And there's 2 standard deviations. You can see there's a 5.93 could be the lower, and then 6.22. So there's a much higher range there with 2 standard deviations. So let's see now if we could answer the question. This slide asks the question, 2 standard deviations is approximately the 95% level of confidence when using a normal probability distribution. What is the minus or plus stages in feet at 2 standard deviations for the 25-year recurrent event? Well, when you look back at that previous slide, you'll see at the very bottom row is the 25-year event is equal to the 0.04 probability. And if you look at that range, it is for 2 standard deviations, it's 6.69 to 8.97. So the answer to this would be B. The point of this is that the HEC-FDA model uses the range of those stages for the 25-year event, not just one stage, in order to calculate damages.